All right, so 3.7, we're going to start looking at trigonometric equations and equations that we're going to be solving. So that's going to be our goal in this section, is to solve equations. And some basic strategies for solving, and it just depends on the problem you're working with as to what you want to try. So you have to decide if the equation is linear or quadratic, okay? That's what you do when you work with algebra equations as well, because the methods are a little bit different. When you solve a linear equation, you move everything but x to one side, right? And then eventually you add, subtract, you multiply, divide, whatever to get x alone, and then you finish your problem. But when you're dealing with a quadratic, you move everything to the same side, right? And you often do something called factoring. We're going to do the same thing when we work with trigonometric equations. If you only have one trig function present, which we will start, our first problem will be like this, you'll solve the equation for that particular function, and you'll see how that works. If you have more than one trig function present, you may end up needing to get everything on the same side. You may end up needing to change trig functions, like you've been working with identities to change them. So in other words, you might want to change everything into tangent or something like that to work with only tangent. And then that's number 4, is changing them using these identities that we're talking about. So let me show you an example. All the ones that we're going to be doing are going to be doing this on an interval from 0 to 2 pi. So you should be thinking unit circle, okay? So we're first looking at this particular one. We have 2 sine x plus 3 equals 4. This is linear. I don't have anything squared in it, okay? So my goal is to get everything on the one side except for x eventually. And to start with, we're going to do that for the sine x. So the first thing I should do is what? Subtracting 3 sounds like a good first step. So now I have 2 sine x equals what? 1. Then what? Divide by 2. You bet. So now I have sine x equals 1/2. At this point, I go to my unit circle, and I think about what my unit circle does. So on the unit circle, there are locations, and it is plural. There are 2 places where the sine value equals 1/2. What are they? Okay, in radians. Pi over 3. Will that give me a sine value of 1/2?
No.
It is pi over 6. It's actually the 30-degree angle, not the 60-degree angle. It is pi over 6. That's one of them. There's one other location on your unit circle that gives me this value. 5 pi over 6. Yeah, it's over in quadrant 2. So in terms of your unit circle, the 2 locations are right here and right here. That was awful. Let's try again. Right here and right here. So we've got that angle and we've got this angle. Okay? That's all there is to it when they only have one trig function. Can I go to the next slide? Because something else is happening on the next slide. What is different about this one? There's a cotangent. What else? There's a number inside with x, isn't there? It doesn't just say cotangent of x. If it said cotangent of x, we would treat the problem exactly like the first problem. Okay, cotangent is a little trickier to work with, but the problem would be the same. Now, bear with me because it's going to start out looking the same anyway. So this right here, square root of 3, I'm actually going to think about this then as over 2. Let's write it this way first. Square root of 3 over 1. Which is the same thing as square root of 3 over 2 over 1/2. Okay, I'm doing that because that's what's on my unit circle, right? Where did the square root of 3 come from? Well, it came from actually taking a look at these particular unit circle values. And when you divide square root of 3 over 2 by 1/2, you get square root of 3. So, and cotangent on your unit circle is x over y, right? So you need to be thinking about where on your unit circle does x over y have square root 3 over 2 and 1/2 values? What radian measures?
Pi over 3.
Pi over 3. So at pi over 3, do I have an x value of square root of 3 over 2 and a y value of 1/2? Is that right?
I was counting on it out there. Is it?
You're almost right. It's pi over 6. Yeah, it is pi over 6. It's okay. So pi over 6 and pi over 3 get confused a lot. Okay, so this one's the pi over 6 one. But there's going to be one other location, right, within the unit circle. What other quadrant do we get where cotangent is positive? Quadrant 3. So what value in quadrant 3 gives me x over y, and I have square root of 3 over 2 and 1/2? It is 7 pi over 6. Now, all of this is going to equal the angle, but my angle is actually 3x, not just x, right? But what happens when I divide some number by 3? What happens to that number? It gets, okay, but it gets bigger or smaller? It gets smaller. When I divide by 3, something gets smaller, right? Yeah. So this pi over 6 and the 7 pi over 6, they get smaller when I divide this by 3, because I'm going to be having to solve for x here in a minute. But the whole goal is to find all of the values on the unit circle. So bear with me a moment while I do this, and you'll see why in a minute. I want to add 2 pi to each of my values. What is pi over 6 plus 2 pi?
13 pi over 6.
And if I weren't restricted to be doing this on the unit circle, this would work too, right? Yeah, because it just goes around the circle again. We end up at the same spot, have the same cotangent value. What about 7 pi over 6 plus 2 pi? That's 19 pi over 6. I want to do it 2 more times, and then we're nearly done. If I take 13 pi over 6 and I add 2 pi to it,
25 pi over 6.
thank you, 25 pi over 6. We're going to do it one more time. How about 19 pi over 6 plus 2 pi? 31 pi over 6. And you might say, well, why did we do that? Do you see how I put curly braces under these? I have 3 of these because I have a 3 here. When I divide each one of these by 3, they're going to be between 0 and 2 pi. Okay? So let's do it real quick so you can verify that I'm not lying to you. We're going to multiply by 1/3, which is the same as dividing by 3. X is equal to pi over 18. 7 pi over 18. Clearly those are between 0 and 2 pi. But 13 pi over 18 is as well. That's still smaller than pi, right? And 19 pi over 18 is just barely bigger than pi, so it's certainly less than 2 pi. 25 pi over 18 and 31 pi over 18. And if you aren't sure because those numbers are looking a little bit weird, you can grab your calculator to confirm. But they are all between 0 and 2 pi. So these are all of my solutions. I got 3 times as many solutions as was on the original unit circle because I have 3x. Okay? We will finish this lesson next time, obviously. We'll look at questions you have from 3.6.